Well, let's start out today with questions. Is it too bright? Is there a bad glare over there? Y'all are okay? Okay, yeah, let's start with questions. And I'm walking to class and I'm like, things felt too light. I forgot my textbook on my desk. So if you have a specific question, I'm going to have to look off of someone's book. Number 25. Can I borrow your book real quick? Just look off of it. Yeah, if you. What page was it? 462. What number was it that? Page 468, number 25. Okay. All right, we will look at it. 16 minus y squared. Is this the right one? Over. All right, so here's the first problem that I've been asked about. This is number 25 out of the homework. Hey, Katie. Okay, so let's go ahead and get this one going. What we hopefully established last time was that when you look at these problems, you're essentially looking at separate factoring problems, right? You're going to look at each of these and you're going to say, okay, let me try and factor each of those and then try and find common factors and cancel. So let's take a look at that top left blue one there, 16 minus y squared. What does 16 minus y squared look like? Difference of squares. Now when you do it, and I'm not going to show it, it should be 4 plus y, 4 minus y. Did you get that? Okay. So that's difference of squares on the top left. Now on the, let's do the top right one, because that one's a little easier. The 10y squared plus 16y, GCF, what's your GCF? 2y. 5y plus 8. That looks good to me. Everyone okay with that? Bottom right is also difference of, not difference of squares, it's also a GCF. I can pull what out of there? 8, and then a y also, right? Yes? Are we doing the bottom right? Bottom right, yes. This is number 25. Okay, so we get 8 comes out, we're left with y minus 4, yeah? Okay. Now the bottom left is a little weird, so that's why I saved it to the end. That does not have a GCF, right? But it is 3 terms. But we normally did not see it written that way. We usually wrote it in descending order, which meant that we wrote it with the power of y, highest power of y first, so negative 20 squared. Then we did negative 27y. And then we have a positive 8, so plus 8. So is it okay if I flip that around like that? And then I'm going to try and do my AC method. So I have to take negative 20, right? Multiply that times 8. And that should give me negative 160. Then I'm going to take the number in the middle, negative 27. And now I'm going to try and come up with all the factors of 160 that could somehow create a 27. And negative 32 and 5. So 32 and 5. And I have to get the signs to work out. So negative 32 and positive 5. Did you get that far with it? Yes? Okay. Now let's look at how you do this with the grouping, because this is important. You take this down here and you look at the outside, right? Negative 20y squared. You write the outside terms plus 8. The inside terms come from those two numbers that we just got, negative 32 and 5. So I have negative 32 what? Y, and then plus 5y. Good. Then we cut that in half, and we do our grouping here. So what can I factor out of the first two terms? Negative, oh, you did the 5? Okay. But you did this one. So I have two different ways. Let me just show it both ways, okay? So if you do it this way, you can pull out, what, a negative 4y, and you'll be left with a positive 5y and a positive 8. And then the other one has to be 5y plus 8. Oh, this one's kind of tricky. What do you put in front of this one to get back this? What do you put in front here to get back this? A 1, right? So you'll have to put a plus 1 there. So that will turn into the 5y plus 8, and then in parentheses, negative 4y plus 1. Is that okay? So when I write that down over here, I get 5y plus 8 and negative 4y plus 1. All right, let's try now to start canceling things. And remember, because this is multiplication, right, in the middle, that means that this multiplication bar goes all the way across, or this division bar goes all the way across, because that's how we multiply fractions. You do the whole top times the whole top, whole bottom times the whole bottom, so it all becomes one big fraction. So I'm just going to drag that division bar across like this, and forget that that dot's there. And so I can cancel anything that matches. Well, let's see, I have a 2 over an 8, so that 8 on the bottom becomes a what? A 4. Now, this is allowed because there's multiplication between everything, right? I'm putting little dots everywhere. I've got multiplication. So as long as there's multiplication between them, I can start canceling. So 2 and the 8 reduce out. I get a 4 on the bottom. What else cancels? 5y plus 8 cancels with this one, 5y plus 8. I also heard a y. This y and this y cancel. Now, well, they're attached to them with multiplication, but you can look at them separately, yeah. Okay, y minus 4 and what? This 4 minus y and this y minus 4 are almost the same, right? They differ by a sign. And that's what you need in order to do that thing where you pulled out the negative 1, right? Now notice the one here, 4 plus y. This one does not differ by a sign from this, right? Why? The y's are the same, aren't they? Positive, positive. Now the 4's are opposite, but the y's aren't. The only way you can get things to cancel with this little trick of pulling the negative 1 is if everything's opposite. So on the top one we have 4, bottom one negative 4, top one we have negative y, bottom positive y. Yes? So you can pull a negative 1 out. You can pull it out of the top one or you can pull it out of the bottom one. It's really up to you. So top? Did you get this far with it? Or? Okay. Well, let me pull a negative 1 out of the top. So I have my 4 plus y up there. Here comes my negative 1. Negative 1 comes out of just that second one, and it becomes a negative 4 plus y. What else is on top? Nothing, right? That's everything, right? On the bottom, what I had was that negative 4y plus 1. I also had a 4. I don't need it in parentheses, but I'll put it in parentheses. Then I had a y minus 4. Now, are these two the same? Yes, right? You have a negative 4 on both. You have positive y on both, so they're exactly the same factor. So I can cancel those. Now, the negative 1 is going to stay out there, right? That negative 1, you don't touch that. It's there. So here's where we are. I have a negative 1 sitting in front of a 4 plus y. And on the bottom, I have a 4 sitting in front of a negative 4y plus 1. Do y'all see how I just changed that negative 1 into just a negative sign in front of this factor? Right there. Okay, if you box that on a test, I'd be happy. But that may not be what the book has. So let me see. Oh, this is your book. What does the book have? Negative 4 minus y over 4, and then, okay, parentheses, 1 minus 4y. That's what the book has. Do we have the same answer? Do we have the same answers here? Yes, because if I distribute this negative through, I get negative 4, and I get a negative y. So that's the top. And on the bottom, I've got a 4 here. There's a 4. And then they wrote 1 minus 4y. I wrote negative 4y plus 1. But if I change mine around, right, flipped them, I would get this. So when I'm grading your tests or whatever it is, I will look and, I mean, if it's the same thing, I'm not going to take off for it, all right? I just don't want you to be doing your homework and then looking at the back of the book and being like, oh, I'm wrong. A lot of times it is you have the right answer, it just looks a little different. Is that good, or do you want me to run through it with the different grouping? You're okay? Okay, what else do we have question-wise? Same page. S cubed plus 8. Over S plus 4 times S plus 4S, S squared plus 4S, over S squared minus 2S plus 4. All right? That's it. This okay? All right, so again, we have multiplication, 2 rational expressions. So we're going to take a look at top left, bottom left, top right, bottom right. And we're going to try and factor each of those. Let's start with the top left. S cubed plus 8. There's no DCF there, right? There's 2 terms. 2 terms tells us, well, could be difference squares, sum of squares, difference cubes, sum of cubes. Well, is it obvious that those are cubed, right? S is cubed and 8 is 2 cubed, right? So this turns into S cubed plus 2 cubed. And by the formula, which you have written down somewhere, right? This should turn into S plus 2 times S squared minus AB, which is 2S, plus B squared, which is 4. That's just what my top left one turns into, right? How about bottom left? Does the bottom left need any factoring? Bottom left, this one here? S plus 4? It's 2 terms, right? But it's not a difference of squares or cubes or anything like, or sum, because the S is not squared, right? So I just leave it the way it is. How about top right? What can you do on the top right? Well, GCF. Isn't there a GCF on it? S. S squared plus 4S. You can pull an S out and be left with S plus 4. So that's what I can do with the top right. How about bottom right? S squared minus 2S plus 4. That's 3 terms, isn't it? AC method, what are the numbers that go in here? 4 and negative 2. Can you come up with 2 numbers that multiply to be 4, add up to be negative 2? No, you're not going to be able to do it, right? So it's prime. Can't be factored. So let me rewrite everything I have here. The top left, the S cubed plus 8 became the S plus 2 then it became s squared minus 2s plus 4. The bottom, just s plus 4, times the top right, s times s plus 4, because we factored out the GCF. And then the bottom right, we couldn't factor s minus 2s plus 4. Now, because there's multiplication happening between these two rational expressions, the s plus 4 on the left and the s squared minus 2s plus 4, those are really in parentheses. So if you kind of just step back and take a look, do you see some cancellation here? The s plus 4s are the same, and the whole s squared minus 2s plus 4 cancels with the other one on the bottom here. How nice is that? And nothing else goes away. So all you have left is the s plus 2 times the s, right? Which if you distribute that s through, you get s squared plus 2s. Now, if I were the one who was giving a test, oh, wait a minute, I am the one who gives the test, then I might give you a problem like this, where maybe the top left was sum of cubes, right? Maybe one of them is, so like this top left is a sum of cubes. Maybe the top right is going to be a GCF. Oh, this one's a GCF. And then maybe one of these will be an AC method. Now, this one was prime, but maybe on a test it would be AC method and it would work. You know, where I give you one problem and there's 3 different techniques that you have to be able to do, right? That's called killing 3 birds with 1 stone type thing, right? Good question. Anything else? Number 25 on the first one. Is this the 9x squared minus 25 one? Okay. 9x squared minus 25 over 5 minus 3x. All right, so we look at the top and bottom separately. On the top, do you have a GCF? No, right? But it is a difference of squares? Is that what I'm hearing? 9x squared minus 25. That's the same as something squared minus something squared. So what is it? 3x, and then over here it's 5, right? If you take 3 and square it, you get 9. You take x and square it, you get x squared. Take 5 and square it, you get 25. So there are the a and b. In the formula, this becomes a, 3x, plus b, plus 5, times a, 3x, minus b, minus 5. How about the denominator? Does it factor? 5 minus 3x? No, right? The 5 minus 3x, there's no GCF. It's not a difference of squares, right? So we don't touch it. On the top, 3x plus 5, 3x minus 5, over 5 minus 3x. And now I'm going to put that in parentheses just again to stress to you that that is an entire factor. It's all by itself down there. And I almost have cancellation here, right? Now, how about these first two? I have a positive 3x. Here I have a negative 3x. That looks good because it's off by a sign. I have positive 5. I have positive 5. They're not off by a sign, right? But if I look at the next one, positive 3x, negative 3x, they're off by a sign. Negative 5, positive 5, they're off by a sign. Since they're both off by a sign, those are the two I'm going to try and cancel. To do that, I'm going to factor negative 1 either out of the top one or the bottom one. So which one? You want to do bottom? You want to do top? Does it matter? It doesn't. You should get the same answer. So I'll show it 2 different ways, okay? I'll do it that way, and then I'll do it this way over here. So if I take the negative 1 out of the top, negative 1, I will be left with negative 3x plus 5. And on the bottom, I would still have my 5 minus 3x. Since those two are exactly the same now, I mean, they're different order, but they're exactly the same, right? They cancel, and all I'm left with is a negative 1, which I'm just going to put a negative, sitting in front of 3x plus 5. Now, can you distribute that negative through? Yes. You could get negative 3x minus 5 if you wanted to. Now, let me show you if you had done it by factoring out of the bottom. 3x plus 5, 3x minus 5. Nothing changes up top. Out of the bottom, here comes the negative 1 out. And I'm left with what? Negative 5 plus 3x. Now these two cancel because they're exactly the same, flipped order. And now I'm left with 3x plus 5 over what? Negative 1. So are those two answers the same? Yes, well, you have to go back and remember how fractions and negatives work. If I write over here on the side, if I write negative 1 over 4, that is exactly the same as 1 over negative 4, isn't it? So when you have a negative sign on the top of a fraction, you can slide it to the bottom. Or if it's on the bottom, you can slide it to the top. Or you can even do this. You can just write 1/4, and in front of it, just throw the negative sign. So here the negative is in front of the 1/4. Here the negative is on the bottom with the 4, and here the negative is on the top. These are all the same. So when I'm looking at this blue answer here, I could just slide that negative up to the top. And then it would turn into this, because that negative would have to have an effect on both terms up top. So it just transforms into that answer. So they're the same. Did I address the question? Okay. Yep. Yeah. If you pull the negative 1 out, make sure you keep track of it. Was that something else? No? Okay, can we come back to 33? I assigned 33, and I realized later that there was division in there. So, my apologies. We hadn't covered division yet. So I will do something like number 33 by the end of today. Okay, let's move on. We're going to go to 7.3. And no, we're not going to go to 7.3. We need to do division. We need to do division. So what we've done up to this point is if we have a rational expression, we've simplified it by factoring top and bottom, looking for canceling. And then we've multiplied rational expressions, and it's the same thing, factor and cancel. Now we have to go and look at how we do division. So recall from some point in your life prior to today that when you had two fractions, a over b, that's a fraction, and you wanted to divide it by c over d, you do not multiply straight across, right? What we did is we said division is the same as multiplication of the reciprocal or something like that. And all it meant is that you rewrite the first fraction, don't change it, you change division to multiplication, and then you flip or reciprocate the other fraction. So the change in the problem is that this flips, right? And also that your division becomes multiplication, okay? That's the idea behind division. So all we have to be careful with here is that before we do anything, we flip the second fraction over. Got to do that first. I'll give you an example with numbers. If you were asked to take 3 over 4 and divide it by 4 over 3, you might jump the gun here and be like, look, the 3's cancel. The 4's cancel, right? You might, but that's going to be wrong because before you can do any cancellation, you have to flip the second fraction over. So this really means 3 over 4 times what? 3 over 4, right? So flip that second fraction over. And now multiply straight across, and you get 9/16. So that's not the same as what you would have gotten had you canceled everything. So just remember to flip before you do any operations. Okay. Ooh, okay. Can I just keep borrowing your book? All right, thank you. All right, so the first problem I want to do with division is this one. Yes, we're still in 7.2. 20 minus 8x minus x squared over 6x squared plus 5x minus 4 divided by x squared plus 8x minus 20 over 3x squared plus 13x plus 12. So now I'm actually paying attention to that sign, right? Because it could be multiplication or division. Right now it's division. So in order for me to be able to do the problem, I first have to flip one of these over. Which one? The one on the right. Okay? So I'm going to flip the second one over. Yes, that means I'm going to have to rewrite the whole problem. Have I already talked to you all about not worrying about wasting paper and, yeah, the sun expanding and all that? Yeah, we have trees. You real big into recycling? Anyone here real big into recycling? Beer cans? Yeah. The sun is going to die. It's going to expand. It's going to swallow up pretty much everything. It's going to recycle everything. We won't have to worry about it. The big recycle will happen eventually. All right. Flipped it over, right? Now it's the problem that we were doing before. So, I mean, really there's no difference today other than the flipping first. And then we have to go about 1, 2, 3, 4 factorings. Right? Now, of these 4 factorings, the top left is the strangest one because it's 3 terms, but they're backwards. So we just did one like that, didn't we? I'll do that one by hand, but the other 3, I would expect, I'm not going to show the work, but you would have to do AC method on each of those, right? And that would all be done on the side, and then you'd bring those answers back in here. So let me do that top left one. I'm going to reverse the order of things. Negative x squared minus 8x. I'm not changing the signs, right? I'm just reversing the order. Plus 20. Now, I could start AC method on that, right? What do you mean if you don't? Well, how do you do AC method when it's backwards? Yeah, as long as when you did your grouping, you know how the 2 ends? Your 2 ends would be 20 and negative x squared. I'm just doing it the way we've done it before, that's all. Does anybody see anything? I had a student in my 9:30 a.m. class see it. That can save us a lot of work. This bottom right one, x squared plus 8x minus 20, is this, but all the signs are different. So if I notice that right now, then I could factor a -1 out of this, couldn't I? If you don't notice that, you have to go through the AC method. But since it was noticed, I will pull a -1 out of this. And what would be left? X squared plus 8x and then minus 20, right? Well, that's pretty darn good. Now, that means that when I put that, if I put this back, right, negative and then this, if I put it back up here, isn't it going to just cancel out with this one? And then I'll still have the -1. But at least all this, I don't have to go AC method, and I don't even have to do AC method on that one either because they're going to go away. And that's just great. Now, I still have to do the bottom left and the top right, though. And those don't match up, do they? So I can't do anything to get those canceled. So let's do some AC method on this one. Let's do some AC method on this one. And let's see if we can get them. Do you want me to actually do it? I can do it. 6x squared plus 5x minus 4. I'm doing that one right now. -20 and 5. What are the two numbers? What is it? -24, yes. That's right. Okay, what numbers give you that? What? 8 and -3? 8 and -3? So you come in here real quick. 6x squared plus 8x minus 3x minus 4. Split it. GCF, 2x. Left with 3x plus 4. I need 3x plus 4 over here. So -1. I really do hope that I've done so many of these, and you've done so many of these now, that you would be comfortable with this. That's kind of the expectation here. 3x plus 4, maybe not this quickly, but you could still get there, right? That's what I get for the bottom left one. And how about the bottom, or no, top right? So I'm trying to do 3x squared plus 13x plus 12. So my thing over here looks like 36 and 13. So what did you say? 9 and 4. So 3x squared plus 9x plus 4x plus 12. Split it. 3x is the GCF out of the first two, left with x plus 3. I need x plus 3 over here also, so that means I need to put a what out there? Plus 4. That gives me x plus 3 times 3x plus 4. So that's the second one, or the top right one. Yep. I'm going to rewrite everything now, okay? I'm going to come back here. We had said that the top left, right? The top left, that all we were going to do is be tricky, and we were just going to pull a negative out. And when we pulled a negative out, -1, we were left with, we said x squared plus 8x minus 20. Okay, the bottom left one turned into the 3x plus 4, 2x minus 1, times the top left one turned into x plus 3, 3x plus 4, and the bottom right one, we're leaving it alone, right? And I'll put it in parentheses, though. Any questions where any of that came from? Let's start canceling if we can. That big old trinomial is gone because the other trinomial is going to cancel it out. The 3x plus 4s cancel, right? Anything else? Doesn't look like it. So I still have a -1 on top. I still have an x plus 3 on top. On the bottom, 2x minus 1. Now, if I want, I can box this and be happy and move on. Or I could distribute that negative through and box it. Or could I have done this? Is that the same? Look at that last one I put here. Is that the same as this? What happened? Look at this one right here. Remember that negative out in front? Didn't I say a negative on a fraction, you could drop it down? If I drop that negative down, doesn't it distribute through here? Doesn't it make it a -2x and a +1? And then can't I just flip the order and make it the +1 minus 2x? So it is the same thing. Again, all I'm trying to do is stress to you that your answer may be correct. It just may not look like what the book wants or what the book is saying the answer is, but it's not wrong. All right. Well, they want you to see that it's the same. Hmm? What's that? Yep. And there's probably some other variations of it. I'll give you the importance of being able to notice that things are the same. I'll share a text I got today, this morning, from a Calculus 3 student. Here's what they sent me. Basically, they wanted me to explain why 3 minus this thing called natural log of 1/4 was the same as natural log of 4e to the 4th minus 1. So this student in this calculus class, and I doubt he'll ever watch this video. I'm not trying to call him out here. I'm just saying this is one of those things where I guess the argument is, well, how could these possibly be the same? They don't even look close to the same, right? But there is a way. These are the same, okay? And you'd have to use these properties in this of logarithms. Who's taking college algebra? Whoever's taking college algebra, you will see this right here. It's a function. It's called the natural log. Anyway, these can be shown to be the same. That's kind of like you coming to me saying, hey, look, I got this, but the back of the book has this. The expectation is that you can get from here to here and that you can see the connection. So it's a good exercise to try and match yours to the back of the book by moving signs around. It makes you better at algebra to be able to kind of do that. Yeah. The schedule should have it. No, the schedule is on the syllabus. The syllabus has the schedule. No one printed it out, right? You did print it? Okay. It's real long, right? Yeah, pull that up and we can talk about that once you get to it. It should be the last. There's. Right? That's it. Let me see if I put it on there. I should have. Our final is on Thursday. Wait, May 15th. So is everyone aware that we only have, after today, we only meet 4 more times in this class for regular class? We have 2 classes next week, and then we have 2 classes the following week. And then the last week is called Finals Week. Do you all know how Finals Week works? Okay. Basically, our class meets on Tuesday, Thursday, right? But during finals, we only meet one of those days. And which day we meet on depends on what time our class is being held. Because our class is a 12:30 class, our final exam will take place on Thursday at 12:30. And it goes to what does it say on there? 12:30 to what? To 3:15. So our final is scheduled for, it's 2 hours, 45 minutes is how long the final can be. Like 100? 150? No, I don't know. I have no idea right now. I have no idea. Let's talk final when we get closer to the final. Like not next week, but the following week we'll talk final. All right. I think it's kind of pretty clear on the final. I'm not going to give you a bunch of problems on factoring. I just probably give you 1 or 2 of these, right? I mean, there's no sense in me asking on the final for you to factor this trinomial, just this top right? Why would I ask you to do that? If I ask you a problem like this, you're going to have to do it anyway. So a lot of the final will be built that way, where it's fewer problems, but they incorporate more of the ideas. Okay, we are moving along. So what we just did was division, right? And we see that division is the same as multiplication of the reciprocal. So let's do another one of these. This one's going to look ugly because it is. xy plus 7x minus 2y minus 14. How many terms you got up there? What are you thinking then? Okay, good. Over x squared minus 16x plus 63 divided by 2xy plus 14x minus 5y minus 35 over 2x squared minus 19x plus 35 times x squared minus 18x plus 81. Now, technically, I need to have that in parentheses like this. Now, this is somewhat similar to that problem 33 that I was asked about at the beginning of class that I said, oops, I accidentally gave you that problem and had division in it. Because this is a problem, we have rational expressions, and we have division and multiplication, don't we? Both. I'll give everyone a few more seconds to copy this. And before we do it, I want to talk about division and multiplication. And we good? Almost? Okay. Oh, yeah. I should have warned you you're going to need space. Did I tell y'all about my pool at my house? I have a pool warmer. Do y'all know what a pool warmer is? It uses the sun. Oh, shit, by the way, let me turn it on. Hold on. I had it turned off because it was not sunny earlier. So this is really cool. I have this app that I can control the different valves on my pool. And so right now I just turned it back on. And so now my pool is, what's happening now is my pump is running and the water, you know how pumps work on pools, right? Brings water in, goes through a filter and goes back into your pool. Well, this one goes in, goes through the filter, then it goes out through this manifold that I built that takes it up onto the roof of my shed, and it goes through these black coils that, you ever see those irrigation landscape black tubing that they use? It goes through 2,000 feet of black coils on the roof and then all comes back down into the plumbing and goes back into the pool. So it's taking the solar heat, right? You know, you've ever put something black outside in the sun, it gets hot, right? So it takes all that heat and the water passes through and it heats the water and it goes into the pool and then it just keeps doing that, right? So yesterday the pool was 86 degrees, which is, for my daughter, she loves 86 is what she likes. So it's pretty cool because most pools right now are about 76 degrees right now. Most like community pools that aren't being temperature regulated, they're still pretty cold. So we get to swimming like about 3 to 4 weeks before everyone else. But all of that I built and it's like just, that was like fun for me, you know. That's cool though, right? Cool app. I know, I like it. I don't do it. Yeah, I could put it on the roof of the house, and it's on the roof of the shed that's next to the pool. It'd be too hard for the house because you'd have to pump the water all the way up, and that takes power. All right. Thanks for, who reminded me of that? I don't even, why did I think? Did I look out and it was sunny or what? That's what it was. The sun came out. Shit, turn on the, it doesn't work if it's cloudy. That's the thing. It doesn't work if it's, but it's free, right? It's free heat. If you try and heat a pool with like gas or anything, it's very expensive to heat a pool. Very, very expensive. We've had it for like 5 or 6 years. Yeah. Haha. I've been to one. I've been to one with the old class a long time ago. It was a summer class, day after finals. I posted all the grades. After the grades went official, we had a big party. It was fun. Not at my house. It was at someone else's house, but it was fun. But this is back, I started teaching when I was like 22, so I was like very young and it was fun. We had a good time. So I know how crazy all y'all are. You know, I know what students are like. All right, so this is a disaster waiting to happen, isn't it? Let me remind you of something. Pool party. What is that? Three times 3? Yeah, what is that? What's 12 divided by 4 times 3? It's 9? Okay. So let's see. We have 9. I don't think I've shown you all this. If I showed you this earlier this semester, I forgot I showed you. 9. Anyone else? 1? Those are usually the answers I get. 9 and 1. I don't think there's anything else you're going to get there unless you do something really weird. Okay, so there's what we call the order of operations, right? PEMDAS, have you all seen that? Please, I learned it this way. Please excuse my no, it's dear Aunt Sally. You've never heard please excuse my dear Aunt Sally? Oh, I was just making that up. I'm sorry. Please excuse my dear Aunt Sally, right? That doesn't make sense, though. Please excuse my dear Aunt Sally. It makes more sense to say, please excuse my damn Aunt Sally. Like, she messed up, right? Excuse her. Yeah. She messed up. Excuse her. Here she goes again. Okay, so what does PEMDAS mean? This is the order in which we agree to do things, right? So depending on how you were taught this, there's a correct way to teach it and there's an incorrect way to teach it. I learned it the wrong way. And I'd be willing to bet my next paycheck someone in here learned this the wrong way too. So parentheses is first, and I agree on that, okay? Parentheses comes first. Then you do all the exponents next. I agree with that. Then multiplication. This is where it's taught wrong, right? These two are together. It's multiplication or division, whichever comes first, as you read it as like a book from left to right. All right? Addition and subtraction is the same thing, left to right. So at least one person learned it incorrectly, and I'm happy to correct it. I didn't actually realize that until a long time ago. And I don't think that it was necessarily that you learned it wrong. It was that whoever showed you that learned it wrong too. And so they just told you the same thing. Yeah. Don't get mad. What's her name, Sally? No? Okay. All right, so when we go back to this problem, we have division and we have multiplication. We will not do multiplication before division. We will do whatever appears first as we read this from left to right. So I'm going to do 12 divided by 4 first and get 3. And then I'm going to do times 3, and the correct answer will be 9. Now, the reason we have to agree upon a convention that everyone does it the same way is because you don't want someone to be, I don't know, building a bridge, and they say, oh, no, I'm going to do the multiplication before the division. And the other engineer's like, no, I'm going to do, left to right. We all have to agree, or else the bridge isn't going to work, right? Things are going to break. You don't want to get an answer. It's like 9 and 1. Those are off. Those are way off, right? So that's the convention. If you type it into your calculator, those who actually have a calculator, we could do all those in one input line, do 12 divided by 4 times 3 on a calculator. It will spit out 9 because it does the correct order. All right, so go back to this. What do we have to do first? We have to do that division first. And that is critically important because if you think you want to do this multiplication first, then what you're going to do is try and look at these two, and you're going to try and get things to cancel here. But you can't do that. You've got to do a division, which means this one's going to flip over, isn't it? And that would change everything. So we will do this division first. All this is really going to turn into is me writing a bunch of stuff again with that second one flipped. What do I do with that last one? Put it over 1. Good. X squared minus 18x plus 81. All of it over 1. Because it is a fraction. We want to look at it as a rational expression, like a fraction, so that it kind of fits into the rest of this. Now that I have multiplication amongst all of these, I can just go about trying to factor each one of these. This, 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 this. And good news, I guess, is that you don't have to factor the 1, right? The 1 is already just there. So how about that top right one, or top left one? How many terms? 4, so I split it. I pull a GCF out. What happens when I pull a GCF out of there? I get what? X comes out of the first 2. I'm left with y plus 7. I need a y plus 7 here, so what do I pull out, or what do I put in front? Negative 2. Okay, that means that top left one's going to factor to be y plus 7 times x minus 2 over. How about the bottom? X squared minus 16 plus 63. AC method, right? What multiplies to be 63? 9 and 7? 9 and 7. So this is going to factor to be x minus 9 times x minus 7. I'm not showing that work, okay? Times the middle one on the top. What's the middle one on top here? Another AC method? I don't recall what it is, so let me do it on the side here. I'm going to use what numbers? I'm doing the top one here. 70 and negative 19. Negative 14 and negative 5. So negative 14 and negative 5. So if you do this, you should get 2x minus 5, and then it should be x minus 7, I believe. 2x squared minus 14. So again, I didn't show that work, okay? I didn't show the work for this one, but that's at least the start of it. Okay, what about the bottom middle? So it's a grouping one, right? And if I group and I pull an x, 2x out, I'm left with y plus 7. On the other one, minus 5y plus 7. So that'll give me a y plus 7 times a 2x minus 5. And then my top right is going to turn to an x minus 9, and that's another AC method. All of it over 1. I hope you're okay with the fact that I left out about 90% of the work there. That's what you get. Okay? Now, can we start canceling things? Yes, because everything's being multiplied. So let's see. I have a y plus 7 is going to go. X minus 7 is going to go. X minus 9 is going to go. 2x minus 5 is going to go. Damn. Okay. All I'm left with is x minus 2 times x minus 9. And then the 1, you don't really need to put it over 1 because anything over 1 is itself. Right? So putting this over 1 really doesn't matter. Now you could box that up, or you could multiply it out like a FOIL. I'm going to FOIL it because that's what the book does. So when they FOIL it and collect like terms, they get this. That's the correct answer in the back of the book. That make sense? Your homework is up here. Okay? I'll write it on here too. Page 468. Let's do 15 through 23. Odd. And would y'all like to start the next section, or you want to call it an early fiesta? Let's end. Now, I did ask you that one problem, right, last time? Let's do this. Do y'all have it where you can tear out and turn in? You do? Okay. Then let's do it that way. Okay? Yes. It's fine. Yep. It'd still be right. Okay. Oh, nice. Extra picture for me. Pardon me? Go over the... You want to talk about it? You had some issues with it? Yeah, I will talk about it. Let's see how many people got it. How many people feel like they got the quiz question correct? Feel good about it? That's it? I don't know. I haven't done it. Okay, so here's what we're going to do. I just want you to be... Who handed this to me?
I don't even know if I wrote it down.
Okay, let's do this. I'll go over it. All I'm going to ask from you, I will not penalize you for this, okay? I'm going to ask you that you don't change your work. If anything, just rewrite something on the back, all right? I want to see what you did, but I'll walk you through the problem, all right? So if you got it wrong, I'm not going to penalize you. Just don't change what you have. Okay, what was the problem? Quickly. Well, wait, hold on. 4x squared minus 24x. Okay, the top left factors GCF. The bottom x squared comes out. Oh, more than x squared. 3x squared comes out. 7x plus 5. Top right, 7x plus 5. 3x minus 2. Bottom, x plus 6, x minus 6. X minus 6's cancel. One of the x's here cancels. So you get a 4, 3x minus 2 on top, and on the bottom you have a 3x and an x plus 6. Now, did you have a problem with a certain part of that? Oh, you wrote the problem down wrong. Oh, that's going to be a problem, yeah. In your final answer, you didn't count? Okay, yeah, yes. 3x. Well, the only thing left on the bottom was a 3x, right, and an x plus 6. So that's this. You just left it like that? Like, you left it like this? On the top of it. So you did this with that underneath it. That's okay. That's still right. Yeah. But if you're going to distribute the 4 through, which is what you did, right? On the top, you distributed the 4 through? Because there was an x squared below it. I had an x, and on the bottom I had an x squared. So that's the same as an x over an x times x, and then one of those x's cancels. All I'm saying is it's not wrong, but if you're going to distribute the 4 through to get a 12x minus 8, you may as well distribute the 3x through also. But it's not incorrect.
Is it incorrect if I put parentheses like on each?
No, it's not. I don't think. What do you mean? I have to see it.
Like I had the same answer as you, but I just put parentheses like on here.
Oh, yeah, no, that's okay. Okay, turn it in. Y'all can go.